you. Thanks for coming. Let's make sure you can all hear me. Can everybody hear me well? Okay. So as Brian said, I'm Anthony Minasali, and along with Mike Jarris and Brian, we started the FreeSWITCH project. We actually began our communications technology journey with Asterisk. We put a lot of effort into Asterisk 1.2 in the really early days of the project. And in 2005, we decided that we had some really good ideas that we wanted to work with in our own sandbox, and not to be, polluting Asterisk with all of our crazy ideas. So we decided that we would make our own project. And basically, in a nutshell, FreeSWITCH is a communications platform that we developed. It's written in C mostly, although it does work with C++ as well in some modules. And it's really kind of just a way to bring together a lot of technology components and different kinds of protocols. And one of our main goals was really about interconnecting things and making a programmable platform on which that we could build applications. So we really liked the idea of having like a PBX and having phone calls and everything, but we wanted to make like a platform that was really excelled at being extensible and being able to load things in modules and change behaviors and all those kinds of things. And then also we had a really big goal of being cross-platform, which was really tricky to keep going, but after 15 years we're still pulling it off mostly. Some of them break once in a while, but we run on most major kinds of Unix, Windows and Macs. So that's been going on for a really long time, but you start to grow with code disciplining when you're always having to work on every platform, because stuff like Windows gets a bad name, but it actually has a really good compiler. So a little bit about what FreeSWITCH actually does. Like I was saying, it's an interconnection of things, like to take other different protocols and move them together. It's quite commonly used in the carrier space as a soft switch, which is something where it takes high density traffic from several sources and condenses it down up into a SIP provider. So a lot of CLECs use it. So it has some things that traditional telephony really didn't need at the time when we built it, but we were kind of forward thinking about it. So we worked a lot with doing transcoding, dealing with different kinds of sampling rates and those kinds of things, because we were always hoping for better quality voice. When we started this, everyone just used ULAW and ALAW, and that was fine. Perfectly designed, a very, very brilliant design ULAW and ALAW from the 70s that still amazes me today. But there was hope that we would have other kinds of codecs that would be higher quality. When we started, we kind of built framework in for it. It really took a while before there were any, but luckily we had the code in there in advance. So when things started to happen, there was G722, which was another older codec that was higher quality. That was the first one we got working, but now we've been working with stuff like Opus, and transcoding to and from 48 kilohertz, and all the WebRTC codecs for audio. So there's some real benefits to some of those things, because you want to be able to play files and record and talk with different rates. You can have an 8 kilohertz caller talking to a 48 kilohertz WebRTC channel and stuff like that. So it's pretty important. So that was something we really wanted to get working from the early days. So also, in the last few years, we started doing video as well. We had kind of support for video all the time, but it was really kind of not that exciting when we first did it, because video, there wasn't enough bandwidth, and everything was kind of postage stamp size, and most of the phones kind of only barely implemented video. Because of Google making WebRTC publicly available, there's a boom in that. And now we've been able to take some of our code and upgrade it to not only doing pass-through, but transcoding a video, so we can put together, do stuff like add drop-in overlays and transparencies on top of the video in real time, or mix the channels together and do stuff like put people side by side and crop and zoom and all kinds of cool things, as well as straight passing through like we were originally able to do. So yeah, and it's really kind of meant to be extensible so that if you get an idea on how you want to make something else, we have a large number of interfaces that are designed for doing that kind of stuff. So I'm going to just kind of overview the core. This is an example of some of the most important parts of the core. You know, we've been criticized for it for a really long time, but we used XML, which was the best format for machine-readable data at the time in 2005. And we kind of used it in a way that was really kind of a halfway between human and machine-readable, because we thought it would be a good compromise, you know, so that a human can edit the XML file and understand what it says, and the machine can easily parse it. So it was a really good solution as far as we were concerned. So we base everything on a single XML registry, which is composed of several different sections. We also have a very robust event system that can scale up to multiple cores as needed, delivering events in a multi-threaded way to all the other modules, and ways for those modules to have their own mini event system inside of that one. Which provides a lot of scalability when it comes to that kind of stuff. We have language modules, which allow you to embed scripting languages or other things. We have one for BASIC. We did as an April Fool's joke once, but it actually works. You can write IVRs in BASIC. But we also support like JavaScript and Lua and Python. So that's kind of like just kind of a fun toy. When I first started using Asterisk, the first thing I did was make a Perl module to embed Perl in Asterisk. That's how I taught myself Asterisk, by trying to just dig into it and make something. So we've been doing some of those things for a really long time, and we carried some of those ideas with us when we started FreeSWITCH. So we have a phrase macro system, which is basically it's a way to take something that might be in several different languages and sort of build a macro so you can refer to it by a common name, and it will translate to the right. When you're doing something like speaking aloud, a bunch of files being spelled out, it will use the correct language and everything, so you can design it without worrying about that, and then put in more languages and stuff later. And we have like a vast library of C functions that you can write modules in and load them anytime, and you know, implement interactions with our core. We have very detailed CDR records. That's something that we really wanted to do. Brian and I did a lot of work on Asterisk's original CDR stuff, so we were inspired to do things slightly differently. So we basically dump out we can format it in XML or JSON. It's all the metadata that we possibly can come up with during the lifespan of the call, like all the digits everybody dialed, whatever we can figure out. If there's room to store it somewhere, we would, and then we just kind of dump it into a giant format that's machine readable. You can offset it into a different system and load things. So we also have a logging engine that you can write modules for and interact with. You know, you can either spit it to syslog or out to a file, or make your own kind of remote logging thing. And just the kinds of modules we have in general, there's several interfaces that allow you to write things that extend past what you get in the core. This is kind of a graphic that we've had for a really long time that describes sort of our view of how we want other people to use FreeSWITCH. So the core is protected. We really try and limit the number of core developers, because there's a lot of dangerous stuff in there that we want to try and keep in the best working order possible, and don't want to burden everybody with trying to manage that part of the code. So then we create an outer API, which is designed for building modules, and there's a full set of functions and stuff that are only meant for modules to use. And that way there's a lot of opacity in some of the code, and that allows you to kind of make it clear where you should mess with stuff if you want to write something. And then over the years, we've amassed several modules. We have so many now, we're actually trying to decide if we even should support them all anymore, because they've come over the years. Like we said, we did a few April Fool's jokes that we actually make as fully working modules. So this chart kind of just shows how they interact with each other, because the modules themselves will interact with the core, and then those modules are basically a glue or gateway layer to some other technology. Like, so if you wanted to add in your own SIP-stack module, you could write an endpoint module and use whatever third-party SIP-stack you wanted. or implement your own new protocol that you just invented yourself. And that's really kind of this slide I should have had up while I was saying all that, but this is the same thing again. So we're going to go through a few of them now. These are the most popular endpoint interface. That's the one that everyone knows because they use it all the time. We have several of them for different technologies. SIP is the most popular, of course, because everyone uses it. We use Mod Sophia, which is Sophia is a SIP stack that Nokia developed that we're kind of the primary maintainers of now. And we've been using it for a really long time. And that's the one that you would mostly use if you're trying to interop with other SIP remote endpoints. And we also have Verto, which is a module we made, a proprietary protocol, which is meant for WebRTC. Very simple last mile control to set up and tear down calls and gateway them into other protocols. So yeah, our endpoint modules are just the interface is available if you come up with a new technology. I can see Giovanni here in the audience. He made one for Skype a long time ago, before Skype killed themselves and got rid of everything and sold it to Microsoft. They used to have a way to actually use their client remotely. There's remote controls for it, and he went through this like really smart way of making a virtual audio driver and a virtual network driver, and tricked the Skype into thinking it was running as a, like a normal front app, but he was hiding it in the background and then piping all the audio in this endpoint module. So like, he was able to take something that wasn't supposed to be possible and made it possible. And he made you made another module for doing cell phone chips, right? Yes, to allow GSM, like a GSM module. So, so engineers like him can decide, hey, I have a protocol. I wish that I could make this scalable and have lots of channels and manage them all. And even the endpoint module is exactly what that's for. Now we have a dial plan module also. The entire job of a dial plan module is very simple. It basically has the earliest metadata coming in. When a call happens, depending on what protocol it comes from, you populate metadata in your channel. And in SIP, it's pretty typically just all the headers from the SIP call and that kind of stuff, and where the network remote address came from. Anything that we try and store. So before we write those XML, dial plan is the first thing to get it. Before we do a CDR, we're already starting to gather some of that data. And that first data is available to you at the dial plan stage, which is basically your module can do whatever it wants as long as it looks through that metadata and decides on a list of actions for the channel to take. So it's pretty simple. We have a bunch of example ones. We actually use that XML registry that I was talking about as a default. It's just an example, but it's very powerful, so a lot of people just stick with that one. It searches through the XML and finds matches using regular expressions, and then installs actions based on that. But you can also, in C, create your own. Basically up to you what you want to do with it. There's just a handful of easy-to-use C functions to add instructions to the channel that you can do yourself. Then we have the file interfaces, and that's a way to implement media files. So just like something like MP4, MP3, WAV. We use a really popular library SoundFile, which basically gives you most file formats for audio that exist. So just by having that one module, we inherit all the file formats that library uses. So we've been using that for a really long time. But we also use libav/ffmpeg for saying we can play audio and video files through that as well. So that we have modules that can gateway those technologies into our core. So we also have flat file support and streaming support, so we can do stuff like play broadcast out to stuff or in, or we can take we can make lots of listeners to the same file stream, so that you can set up like music on hold or something by having like a back end player that just kind of cycles through the playlist, and then you can attach to like as many channels as you want to the same interface. So that's pretty popular. So we have an ASR and TTS interface, which is specifically designed for loading in technologies that do ASR and TTS. You know, like saw Lemon Box was here. That's an example. You can write a module for that if you wanted to embed it right in. So we have all these paradigms that are higher level that you can write applications to listen for ASR and to use TTS all over the place. So if you just write a module for a new technology, you can reuse all that same higher level code using the one you want. So we have we have some commercial ones too for supporting like Watson and Google. But by default, we have Sphinx and Pocket Sphinx that's in there, which works okay. It's all about the training data, really. Okay, so we have the say interface, which is more like the old school just playing the right file at the right time thing, like you have one message. We have a whole bunch of ways to do that, and it's multi-language. Works pretty well in a lot of cases. That's been there for most of the life of the project. We're hoping that that'll start to be obsoleted now that Google is making Dialogflow and other natural language stuff that we can interface with so that you don't even have to do that anymore. Chat is something that we have also. It's basically a way to take outside chat interfaces and do stuff with them. We have a similar dial plan for chat that's specific to that. So you can take SMS messages and bring them into our core and parse them, and using code like Lua, you could to write a response that you want to send back out and make your own little bot if you wanted, and stuff like that. And the chat interfaces gateway into each other, so the conference inherits it. And we have support for real-time text and a bunch of other stuff that companies that enjoy doing stuff for impaired people really find that useful. They use our RTT interface, so you can type things in real time while you're on a call with somebody. So then we have the limit interface. That's basically all about this abstraction of the logic about like how many of something is allowed to happen at the same time, which is just kind of a generic problem. Like how many calls can this one user have at the same time, or how many times can somebody call this extension, or there's just like a whole bunch of different paradigms that have similar requirements. So we have a limit interface that you can make your own backend. So there's one for like Redis and one that just uses the database, a little SQLite file or something, and we have one that uses in-memory hash. And so you can implement that as a backend module and figure out your own best technology for doing that, and then on the outside you're just using the same higher level code again so that you don't have to change it, but you can make a better backend later. So codecs are a very popular module type. We have a lot of those. Basically that implements an encoder and decoder for audio to be moved over the internet. I was talking earlier about ULAW and ALAW being the most popular, and of course we have those right away. I don't even know how many codec modules we have now, but we support basically any codec that has a library that you can load. There's some proprietary ones we don't have access to, but if we had the library, we could easily make it. It works for both audio and video, so we have the most popular one these days for audio is Opus because it's got really good resiliency and forward error correction and packet loss concealment depending on the way you use it. But there's still a whole bunch of them, like Isaac and GSM, and anyone who uses Asterisk would be familiar with that. There's codec modules there too. It's very similar in design for that. So now we have the application interface. This is really kind of like a little sandbox for you to write something to manipulate a call. So if you want to write an application, you can use those dial plan instructions to route your call to the dial plan into one of your applications. So you can either use one of the many, many, many applications that are already part of FreeSWITCH that we provide, like conferencing and queuing and all that stuff, or you can make your own, write it in C. It's very simple. C is not exactly the world's easiest language, but our kind of framework is not very complicated in comparison. We have our own kind of native set of functions and stuff that anyone could figure out how to use. And you can basically, some tougher stuff is in there, like if you wanted to actually like get raw audio out of a live call and poke at it and like manipulate it and do stuff like that, it's a little more challenging, but like doing stuff like setting variables on the channel and that kind of thing are pretty simple. Applications are where most of the stuff happens. The most popular application might be the bridge one, because that's what people use to make calls lead to somewhere else. You know, they'll make an outbound, inbound, and outbound call matched up. That one gets used a lot, and the conferencing gets used a lot. And then there's just a whole bunch of little helper applications. So if you're developing your own kind of solution, then you can control the order that those are used and put hooks and have them executed at certain times. Like we have a way to, you can pre-set an app to execute at the time when the call is answered, but you can put that in the dial plan ahead. So there's all kinds of versatility with that, and I could probably give a whole speech just about that, so I won't go on with that too much. So the last one I want to talk about is the FSAPI. This is a very generic kind of data in, data out format. It basically takes any blob of text in and spits back out another blob of text. So you can use that to create console commands. And you can also make, you know, this remote APIs you want to execute. We have a way to use a remote socket to, you know, connect from your own middleware or whatever. And you can execute FSAPI commands as many times as you want and use that to kind of remote control calls. So you can set a call up and tell it to do things, including side loading listeners on it, or tell it to start recording and that kind of stuff, as well as like writing direct applications in it and collecting digits or whatever. Depending on the use case, it pretty much covers everything from some commands that you could actually type yourself at our console to like more elaborate commands that are only meant to be used through a program. If any of this is interesting at all, we have some books on, from PAC Publishing. We don't actually sell them, so it's not really gonna, it's not like I'm trying to sell them to you guys, but if you care, there are books out there that PAC Publishing sells. Now, some of the newest thing that we've been working on in the last almost 4 or 5 years now is WebRTC. It seems like it wasn't that long, but I just counted the years on my hand and I'm surprised to see that. But one day, you know, Google released this. They took the GIPS media engine and released it as an open source project. They installed it into their browser, and it became like a good idea to try and keep up with it. So we started out implementing the audio and then eventually the video as well. And so now we have the ability to use a browser as an endpoint. The bad news is that they've decided to do everything completely different from ways that we knew. I was a little excited in the beginning thinking that it was just going to be an extension of all the stuff we've all been doing for many years into the browser, but really it's kind of only sort of like that and is a little bit more challenging than it seemed at first. But we have been keeping up with it and implementing as much of it as made sense. So we have the ability to terminate. We have our own WebRTC stack. Most of the other applications that use WebRTC today just load that open source library. But since we have deep integration with some of the stuff we've already done, we really kind of had to just add the extra WebRTC functionality into our existing media stack. So we use the same media stack for SIP or for Verto, which is our proprietary protocol I was talking about, and you can change between them at any time. So you can use the SIP stack that's written for a browser and connect with our WebRTC stuff as well. Or you can use Verto, which is just designed to be as simple as possible and to add extra communication channel, which is basically exposes a few of those things that I had been talking about. It's an endpoint. It has a gateway to do FSAPI commands if you want, as well as the chatting. You can gateway the chat through it, you know, right, a little box in the browser. One of the most popular uses of this Verto module today is conference calling, because we have a bunch of metadata that we send in real time about what's happening in the conference that allow you to make your own displays. Like you want to have someone's face light up when they talk and all that kind of cool stuff, straight through the WebSocket. So that's kind of a convenient thing so that you don't have to write like 2 different systems and have something else going back and trying to figure out how to connect to that info. So yeah, on the other side we have a JavaScript library, which runs in the browser, which implements the client side of the Verto protocol. And that one is, it's basically, you can take that JavaScript library and create a Verto endpoint object and embed it anywhere inside of your existing web page. And when you can kind of make your own phone if you want, or any other kind of thing that matches the paradigm of like establishing an audio and video call out to the server. So people use it for some creative things, like job interviews, you know, or you just go in there and record your job interview and then it saves it. Or you can do like, a lot of people just use it for having one-on-one video chat. Or you can use our MCU stuff, and there's all kinds of cool overlays and things that we ClueCon Weekly that's actually going on now, I think, in 15 minutes. It's a podcast type thing we do, and we use our own conference and FreeSWITCH to produce it. So if you ever go to our YouTube channel, which is just YouTube/FreeSWITCH, you can see older ones. You can actually see the evolution of our development efforts because we use it as a testing ground. So the very first one, everyone's all janky, you're going, hello, whoa, whoa, whoa. And by the latest ones, we have full 1080p video. So it's really kind of a testament to like all the work we did. And so at the end of this, we put a lot of time into making FreeSWITCH. We realized that there's a lot of different options and there's a lot to explain. As I've gone over some of this already, I don't know how interesting this is to you guys and how deep you are into being developers, but some developers want to get down really deep and write C code, and some of them want to just kind of have access to an easy way to build applications. And what we decided to do after this time was we really want to keep our FreeSWITCH open source project going. So we have all these options still, and the code is available as usual. But we decided that we wanted to also start a new service, which is called SignalWire. And kind of the benefit of that is it gives some of these features that are really kind of hard to work with and understand at the fundamental level, and add one more layer of simplicity to it so that it's more mainstream. And can be bundled with stuff like telephone minutes and phone numbers and the ability to have your own clients, and it just kind of gives developers something more tangible towards their products to work on instead of like having to commit so much time into digging into code and learning how to do like all the complicated stuff. So we welcome anyone that likes to do that, and we'll enjoy talking to them about it. But if any of you guys are also interested in some of the other features we have, that's why we had SignalWire. And it really kind of provides a home because the entire engineering staff that makes the project is employed by the company. So that's really kind of powerful for a FreeSWITCH project now, because all the effort that we put into making our products end up trickling down into the open source, which is a very good ecosystem. We just started it basically in January, like the last few days of December in 2017. And we just started going into public beta now, and so we're doing a promotion if anybody wants to try it. Like, there's no commitment. You can sign up on our website right now, and there's $100 credit. We have really disruptive pricing, so that $100 could last you a pretty long time if you wanted to play around. And in the beta stage, one of the things we really wanted to bring to the industry is the ability to also develop stuff that people want. So we're feedback driven. As well as the things we offer and the roadmap that we have, we do allow some influence to come from our end users because we really appreciate the feedback. And we learned from years of doing FreeSWITCH that that kind of feedback is really what drives the development of software. So that was basically it, and we can talk about questions if anybody has any. I have some time left, I think.
What would be the top 3 reasons why someone might want to use FreeSWITCH instead of Asterisk?
Of course, that's the only question to answer. And I have to have three you asked for too, right? The top 3 reasons, let's try and find one first. I try not to, we're not really competitive as far as open source goes because we all came from the same roots. But I'd say if you were interested in some of the things that Asterisk doesn't have a focus on, like the great number of like application server development stuff. You know, there's a lot of, Asterisk is an amazing phone system that has all kinds of functionality that you can build ISPs from and stuff like that. If you want to have something, I think that is more like a place, a sandbox to develop something, a product out of it. I find that a lot of our users build embedded products with our stuff, so I would say that could be one thing. I'd say that if you already are using Asterisk, it's a good complement to it. A lot of people use them both at the same time because there's really kind of there's a lot of similarities, obviously, because you know, Brian and I and Mike started out as Asterisk developers, so there's a lot of inspiration for it. But we have some things that I think are pretty complementary. Some of our video stuff, Asterisk has some great SFU model now for doing forwarding of video, but if you want to do anything where you're actually manipulating the video, recording it and broadcasting it to YouTube and that kind of stuff, or being able to modify the video in any way, to transcode it to other codecs, to make it H.264 and BPA at the same time in a conference and that kind of stuff. So it's really kind of, like all things, the right tool for the job kind of thing. So I try not to self-proclaim that anyone should use our software. But being an open source, we're just glad that people try it and the feedback is really valuable to us. Yep.
Does FreeSWITCH work with Digium's analog cards?
Yes, actually it does.
It does?
We have a, so we have a module called, well, we have a library called FreeTDM, which loads, implements one of the endpoint modules, and that FreeTDM has its own modules, in turn has some physical hardware card ones. So we have one, it's not, there's a daddy module for FreeTDM. And it's not super shiny. It's basically just like the core functionality, but we have that. It works with Stingoma cards as well. TDM has really lost popularity amongst our users, but we still have that, and it was really fun to make. I remember when I first implemented that, you know, and getting to generate my own dial tone, you know, using all the sine wave code and stuff was really fun. But it's really kind of like, it hasn't changed in a really long time because there's less use for it, but I'm sure that it still works.
Can FreeSWITCH hold a call when you have failover, and if so, how's that happen?
Failover such as like surviving a crash or losing
Yeah,
the
surviving a
network or
crash
something?
in the first
Yeah, so I was
instance.
telling this story at the party last night. Actually, I can't remember the exact year. I think it was like 2010 or something, somewhere around then. Someone came to me saying they wanted to do a master's thesis on this concept of recovering SIP calls by pretending that it never crashed, but just simply doing a reinvite to reestablish the dialogue. And we got interested in that. And I don't know if the guy ever did his master's thesis, but I think we did it for him because we got really intrigued by the idea, and we implemented this thing, this recovery thing. It actually is abstract to all endpoint modules, but each one has to implement its own kind of recovery mode. So like in the case of our SIP module, it works with that as far as you have to add some complexity because in order to be able to do it, you have to store more data. But we have a thing where if you turn it on, every time there's an important thing in the SIP call, it'll stamp down all the metadata necessary to reestablish the dialogue. So if it crashes or something, there's a recovery command you can put at the beginning of your startup, and it'll dig down into a database of all the calls that were up before it crashed and just like jump back into place and reinvite them. You can use that to make, I think Giovanni knows a lot about that, so you can talk to him. He likes to play with that feature a lot, I know. And also our Verto module supports it as well, so we can we can have a video conference with like 10 people chatting, and sometimes I do this to the guys while we're working, because we use our own server to develop stuff, and I'll just reboot the server randomly, and it just goes, it looks like it's dead, but then it just pops right back up and all the calls resume again. So in our Verto protocol, it's a little easier than SIP because we made the protocol, so we don't have to work around like weird idiosyncrasies. But yeah, so like if you made a new endpoint tomorrow and there's a way to recover those calls, then you can work into our recovery framework and actually implement the routine. There's a core routine for the basic FreeSWITCH channel itself, and then each endpoint has its own kind of protocol-specific recovery stuff that you can implement. Yeah. Yeah, so if you want to do stuff, you can leverage that same feature to jump networks. Say you have two servers that are in different networks, and you can make the IP jump over to the other one. Or really, with some more creativity, you could actually just take all the calls and pick a different box to put them on. There's all kinds of fun things to do with that. So yeah, it's not. It's all just kind of out there. And Giovanni puts a lot of work into making how-tos and tutorials on that functionality, actually.
My question is, how many video participant can be on the MCU unit? And if it's maxed out, can you cascade it to the second box?
So it's kind of dependent on the number of processors that the machine has. So we have several different behaviors for our video conference. One of them is a reusability of the encoder. So we use a lot of threading in our video conferencing to try and scale as far as possible. So you can do, you can decode all the video as normal, and then rather than re-encoding it for each participant, we prepare one encoded video and stream it to everybody. So you can turn that feature on if you want to be able to kind of like scale higher. I've seen 50, and it starts to get ridiculous to have 50 people in an MCU, but if you have a nice machine, you can get that high. As far as cascading over to another one, since we're doing mostly MCU stuff, we don't have much in the way of forwarding. We do have a pass-through mode that some people use together, so you can put the pass-through conference with a bunch of MCUs together so they can share the view of a pass-through conference. So there are some ways to do that kind of stuff.
To be clear, we have two different ways to do a video conference. One is extremely light on the CPU. It just moves back and forth and gives you the advantage of server side, but is kind of light like an SFU, like the FreeSWITCH one. It just doesn't put two persons at the same time in the screen, doesn't mix the video. Because mixing the video is like Industrial Light and Magic, it's like Star Wars, and it takes a lot of CPU. So that second way, so we have this one that is very light, and we have the heavy one that permits you to have, I mean, we demoed with 64 people at the same time in the video. That's kind of crazy, but we can do it. And a lot of interesting things like putting the caption, so who you are, what's your function, or having a scrolling text, or you know, all these kind of things. So we have both things.
Yep, thank you.